easiest concept that we probably heard of Langchain for is to develop chatbots. LangGraph, though, is a little bit different. And I think the key thing here is cyclical, not linear.
Hey, what's going on, everybody? It is Thursday, and you are watching the Daily AI Show live. Today, we're talking about Agentic frameworks, specifically Langchain's latest innovation, LangGraph. And Langchain is an orchestration framework for building intelligent agents, meaning agents that can operate autonomously to perform tasks. And LangGraph takes this further. LangGraph takes this further by creating autonomous AI-powered agents that can not only operate autonomously, but also continuously learn and adapt. So that's the difference between them. And with me for today's discussion is Andy, Jyunmi, Karl, and I'm Beth. And Karl is our resident expert on all things Langchain. So I'm going to toss this over to Karl.
We're going to be talking about LangGraph, but before we get into LangGraph, I think it's just a good overview to get into what is Langchain first, because LangGraph is kind of the evolution to that. And then we also have to define the concept of AI agents, because that is what LangGraph is for. So first of all, Langchain, some of you may or may not have heard it. It's an open source framework to simplify the development of applications powered by large language models. Now, the most common concept or easiest concept that we probably heard of Langchain for is to develop chatbots, right? Where you can use chatbots, but trained on your data. Now, we've probably seen a lot of use this chatbot to chat against your PDF. That was, I think, one of the very first concepts to be built with it. There's other ways to use it, but you've probably seen lots and lots of different applications. I think Humata.ai, ChatPDF. In fact, all the base chatbots that actually started, like even ChatBase when it first originally came out, they were all built on Langchain. And it's supposed to streamline the applications. It was actually developed in October 2022 for those who code Python and JavaScript. And it's really the backbone of a lot of how you build certain things. Now, if you want to learn more about Langchain, there's tons and tons and tons and tons of resources to it. But what I want you to know, to keep it simple, is that Langchain, essentially, we're chaining applications together, but it's linear, right? So when we think about this, let's talk about from an agentic perspective, there is agentic qualities, but it's like, if you do this, it does this, it does this, it does this in terms of tasks. So does one task to one task. So let's take the chatbot example. I feed it a PDF, and we ask it a question, and then it's executed. So it goes to it, takes the PDF, breaks it apart, it puts it into the, it's already broken apart. But if you ask a question, it goes into the vector database where your PDF has been broken apart, finds, semantically connects it. Again, if you want to learn more, go look at it. Go do your research, but semantically breaks it apart. Looks for the semantic connections and then has the answer to it. Very linear. This is what you're supposed to do. Now, LangGraph, though, is a little bit different. And I think the key thing here is cyclical, not linear. So what do I mean by cyclical? When we talk about Langchain, it goes from one to another to another to another. I'm going to show you a really quick video here of what I mean, but I want to prime everybody for that. But with LangGraph, and in terms of agentic qualities, there are certain things you want an agent to go back and redo the step. So let's go back to the chatbot, right? So if you type in a question, it goes to the vector database and it gives you the answer. But if we use LangGraph, it may think, wait a minute, I'm going to recheck this and I'm going to go back. That's that. It's going to go back around. Just bear with me for half a second, and then I'll show you what that means. I think we have to have the definition, or the folks at Langchain's definition of agents, which is a system powered by a large language model to make a decision. And that's really what we're looking at here, where in Langchain, it's, again, vertical. There are no decisions being made. It's pretty much, this is the flow. But with LangGraph, it makes a decision which node comes next. All right. So I've been talking a little bit more, but I want to show exactly what I mean by this.
So, providing the modules and tools needed to build AI applications based on large models. Just a few days, Langchain officially announced the new library called LangGraph. LangGraph builds upon Langchain and simplifies the process of creating and managing agents and their runtimes. In this video, we will introduce a comprehensive of LangGraph, what are agents and agent runtimes, what is the feature of LangGraph, and how to build an agent executor in LangGraph. We're going to explore the chat agent executor in LangGraph and how to modify the chat agent executor in LangGraph in humans in a loop and chat. So, what are agents and agent runtimes? In Langchain, an agent is a search model that makes decisions about actions to take. An agent runtime is what keeps this system running, continually deciding on actions, recording observations, and maintaining this cycle until the agent's task is completed. Langchain has made agent customization easy with its expression language. LangGraph takes this further by allowing more flexible and dynamic customization of the agent runtimes. The traditional agent runtimes was the Agent X class, but now with LangGraph, there's more variety and adaptability. A key feature of LangGraph is the addition of cycles to the agent runtime. Unlike non-cyclical frameworks, LangGraph enables these repetitive loops essential for agent operation. We're starting with two main agent runtimes in LangGraph. The agent executor is similar to Langchain's but rebuilt in LangGraph. The chat agent executor, which handles agent states as a list of messages, perfect for chat-based models that use messages for function calls and responses. Definitely stay tuned throughout the end of this video. If you guys haven't...
Okay, so I'm going to stop it right there. And we kind of touched on a couple key elements of LangGraph and Langchain. So I want to, before we go any further, are there any questions or comments or maybe discussions that we want to get into?
Yeah. So when you were talking about the vertical or, step-by-step orientation of an execution within Langchain, the term serial process, was flashing in my mind. And then when you went to cyclical, I was thinking, well, cyclical just sounds like within a series you stop and repeat some function. But what I expected to hear, and what I wanted to hear, and what I want you to make the distinction about is there a parallel process possible for an agentic workflow in LangGraph where the agent says, okay, first of all, I've got to figure out how these steps that I'm going to take, and I'm going to launch multiple of those steps at the same time and have them process until I get a result. Is there any parallelism in the workflow management in the LangGraph that didn't pre-exist in Langchain?
So the key, there's a couple key points in there in terms of LangGraph. So we didn't get into really the deep points of the executor and the agent runtime, but there's a couple points that are key in there. So there is what's called nodes. There's the graph itself, the nodes, the flows, and so what a node is essentially what you want it to do. And then the flows are just connecting it all together. But what's really interesting about LangGraph is that you have the human in the loop. It enables human intervention at any point in those nodes. So if you build it in a way, a human can review it at any point during its series as it, executes, along the path, that a human in the loop can make the decision. That's the human in the loop. But what's really cool, like what I mentioned before, is in terms of agents, is that it's powered by them to make the decision, right? So think about it as if you in LangChain, it's linear, right? So like you go from one point to another point to another point to another point. But with LangGraph, it's like you go to one point, then it decides, do I go this point, this point, this point, what next node do I decide? And then, but because of its, when we say cyclical in nature, it goes to one point, and if it decides, hey, I need to go back around, it'll do it again and again and again. But based on how you build it, maybe it'll stop the cycle and then go to another node and then to another and then complete a different kind of cyclical nature until the instruction is complete. So that's...
So the workflow then appears like a graph that has interconnected nodes and is not a serial chain of steps.
No, it's not like...
It stands out, in effect, because you have choice points where there's branches. So you have branching possibilities, and you're saying that the LLM gets to decide how to branch, which branch to take when it reaches a node.
Yes. And now, there are limitations to this, though. There isn't something where you can just say, hey, I want you to build for me a complete system of applications to get a bank account for me and set up my own business. The reasoning of the large language model is not that level yet. Hence, it can't. I think that's the limitation of a LangGraph, is if you get higher reasoning, so let's say GPT-5, GPT-6, then the decision-making between nodes can get more complex. So it's, instead of being serial, right now LangChain says it's more complex workflows. Complex as in it's more complex than linear. But if you take the reasoning even higher, it's like, well, maybe if we do this cycle once, we'll go this cycle again, we'll come back, we'll do multiple cycles so it becomes more like your graph becomes bigger and bigger and bigger and bigger and bigger.
Mm-hmm. But it's not creating it for you, right? That's the distinction we're making in terms of how agents are defined, like how you define agents earlier. So you're not telling it, make all these nodes. You're establishing, I need these nodes and I need you to run it. You figure out the best way to run them.
Yes, and correct me, I said flows, I actually mean edges. So there's nodes and then there's edges. There's actually another, there's a quick little clip that I wanted to show you what I mean by nodes and edges.
So this is not a DAG or a fixed directed graph in any way. This is basically where nodes can make decisions about which node they can go to next. So another way of thinking about this is it's like a giant state machine that you're building, where the graph is basically the state machine that decides, okay, what state are you in now? What state will you go to run a particular chain or to run a particular tool, etc.? And then how do you get back? And then also things like, how do you know when to complete or end the graph or end the sequence in here? So LangGraph is built on these ideas of trying to make it easier for you to build custom agents and to build things that are more than just simple chains with LangChain. So there are a number of key parts to this. You've got this idea of a state graph. So this is where your state is being persisted in some way throughout the agent's life cycle. And you can think about this as a sort of way of passing the dictionary around from chain to chain or from chain to tool and stuff like that, and then being able to update certain things. And you can update things or you can just overwrite them, or you can add to them. So if you've got a list of things like immediate steps, you can basically add to that as the agent is actually going through running the various parts of the graph, etc. The next part, which is key to this, is the whole idea of nodes. As you build the graph, you want to add nodes to the graph. And you can think of these nodes as being like chains, or actually they're also runnables. So it could be a tool, it could be a chain, and then you can have a variety of these different nodes. And you think of those as being like the components of your agent that you need to wire together somehow. So while the nodes are the actual component, the edges are what wires everything together. And the edges can come in different forms as well. So you can set an edge where it's just going to always go from this node to this other node. So if you have a return from a tool going back to the main node, you're just going to let that, you're going to want to probably hardwire that in there. But you can also then set edges which are conditional edges. And these conditional edges allow a function, often going to be the LLM, to actually decide which node that you go to next. So you can imagine that this can be useful for deciding if you're going to go to a tool, what tool you're going to go to. If you're going to go to a different sort of persona in the agent, let's say your agent has got multiple personas and you want to go from one to the other.
So I'm going to stop it there because I want to go back to, essentially, I just want to keep it really simple and go back to this drawing that he did, this one, where he goes into nodes and then the edges. So these are the edges, these are the nodes. And then again, when he was saying conditional, if he goes here, if it comes back. So, and then the cyclical in nature. So I know it was a lot of code and I liked how he explained it, but I didn't like, he just put code up. It's like, if you drew it out, it would actually be much better. So that in a nutshell is what LangGraph is.
So I have a question for you to try to see what the import of using LangGraph and its ability to do conditional branching, in effect, in its processing of these various nodes, which are functions or tools. Going back to the chatbot example, you described the Langchain implementation, that serial or direct, no branching at all. Just if you finish this step, then go directly to this step, and so on. And you described it as, okay, we have a message from the user. There's a semantic comparison that's done in the vector database, and that's this retrieval augmented generation. It goes out and gets the data from the vector database and then uses that, the LLM uses that, then to produce a response. Now, what is it that's possible with LangGraph now that is an augmented use case example for an interactive conversational LLM session that LangGraph enables that wasn't possible with LangChain?
So, okay, there's a couple things that we could add to this. The first one, which I think a lot of trained chatbots or chat against data, is that it can't remember previous conversations. So let's say one day you wanted to chat about let's keep the PDF example. Let's say one day you wanted to chat about the introduction of a PDF, of a PDF, whatever topic it is. Then 2 days later, it won't remember that context. But 2 days later, with LangGraph, if built correctly, now it can remember what that state that you were in, and then pull from that state and then put it back as context to your conversation.
Right, because it literally updates the state of the node, right? So that piece that it keeps going to say like, okay, this is my thing. When it goes to the second time, it can update it when it's there.
That's part one. Part two is, if again back to custom built chatbots too. Do you notice that it doesn't really come back and ask you questions? Come back like ask follow-up questions, because as in normal conversation, we clarify each other. You're like, oh, what did you mean by that? Did you mean this or this? I'm not, to get a little bit, doesn't do that. It's usually, I ask a question, you provide an answer based on your vector database. That's usually it. Maybe you can provide a couple more follow-up questions, but it's pretty simple. But now you can do follow-up questions, you can clarify the intent, and then provide that, which is very important because once the multimodal aspects of it, where you can interrupt real time those type of conversations, that is key, especially if you're building a custom chatbot using like GPT-4o. It is important to have a system like LangGraph where you, back to the cycles, it's like, oh, I ask if I don't know this because the query didn't include this information, I'm going to go back and ask what it is. So it goes back and clarifies that. And then maybe because of that clarification, it can be more specific in what it's pulling from your vector database versus, oh, you said this, I'm going to pull everything that is semantically related to your question and then hope and a prayer that it answers the question. That's where you get either the hallucination or you have to really prompt it, or the custom instruction has to be very specific in what you want it to do, right? This allows a little bit more. Now, take it one step further, is because there's that human in the loop feature, you can also, let's say you wanted to execute, hey, book me this is starting to get the agentic features to it. You type in, book me a demo for this product. And then it goes out and, executes that. But now with the human in the loop, you can say, whoa, wait a second. You know what? Can you book me a demo for next Tuesday? But could you also check if that's available? Or could you book this demo on Tuesday if it's a multiple product, but this demo on Thursday? But check if the time is available. And then that's where the complex workflow starts coming more and more and more and more. And then I think the last piece is the scalability, because then you can have these multiple pieces that you can start scaling, which enables it more reliability for businesses, where it's not just a very specific point. Now you have multiple agents. You can do more things with your, say, chatbot.
Well, I had two questions. I don't know how quick they'll be, but question number one is, Karl, do you have an analogy that encompasses what LangGraph does? And two, do you have a use case that, or whether it be a simple use case or what you expect as a prime example of how Langchain will be used?
So give me a second for the analogy. Let me quickly think about that. But I did pull up because I've built with Langchain, but I haven't really explored deeply with LangGraph. Part of the reason why I have explored with LangGraph is that I feel because the reasoning capabilities will increase, my question is, do you really need the LangGraph when you have a large language model that can execute this because of its reasoning? And that's more of a hypothetical, more of a theoretical type question, right? So I pull up a really example of like real-time market analysis, in finance. So you implement you use LangGraph multi-agent, again, lots of agent cycles to analyze real-time market data. Now, I don't want us to think about this in silos. I want you to think about this paired with all these other news and announcements. So we saw that OpenAI bought Rockset, right? Rockset is this real-time ingestion of data where you can ask against it. So imagine LangGraph combined with Rockset type capabilities. You can add, as the market or wherever a data is being pulled from the marketplace, stocks and so on, analyze real-time market data, perform the sentiment analysis, generate those investment insights, at the same time pulling from your portfolio data, right? So imagine it understands your portfolio data while it's analyzing in real-time market data, providing that financial advice to you. One more step. Let's say you interrupt and say, hey, I don't want you to just analyze my portfolio data. I want you to analyze my portfolio data in this specific sector with this specific segment of my portfolio. Again, starts becoming more complex and more complex and more complex. Now, add that to, let's say, Apple Intelligence, where you have all the things that you've, let's say, emailed about, researched on, combine your, I guess, search and social history and what you are interested in, put that all together. What does that give you? Hyper personalized financial analysis, real-time market analysis against your portfolio, your retrieval augmented generation, plus everything that you've done, all combined in real-time analysis. That to me is what are really the power of what we're looking at.
So before Andy asks his question, I want to pop in Justin's question from the chat. So LangGraph can enhance memory, continuity, and consistency, making it better for agentic functions compared to RAG. Is that, or is Justin on the right track?
It depends on what you mean by memory, but yes, it can, because a simple RAG, again, is back to linear, right? So it's like, if I ask this question, it's going to go in here and it's going to pull it. But from a memory side, which I just talked about, yes, because it remembers the context of what you said, whether it's in the conversation. So it remembers, hey, 5 questions ago, you asked about, let's go back to finance. You asked about your portfolio in the medical field, but now you're asking about the biotechnology field, but there's a connection. So it remembers that. So that whole conversation piece becomes even better. Yeah, I hope that kind of makes a lot of sense. And to answer your question, your about an analogy, I kind of use Perplexity as one. So LangGraph as a conductor. So imagine LangGraph as a conductor of an orchestra, right? Musicians represent the individual agents or components of a chatbot. The instruments are the tools and technologies each agent uses. The sheet music is the predefined workflow script that guides the interaction. And then the conductor, which is LangGraph, coordinates all the musicians to ensure they play in harmony, following the sheet music to create a beautiful symphony.
So where is the node in that? Is the node the sheet music?
The node would be the sheet music. But here's the really cool thing, though. Do you know in high school I was in jazz band, so I remember this too, and I played the tenor saxophone. So there were times you get solos, right? And it's not in the sheet music. You're still following the flow of the song, hence the goal, but you go up and you can, you can freestyle for however long you get. Multiple people freestyle, and sometimes, depending on the conductor and based on the conductor's experience, they're like, hey, we're gonna keep the freestyling going a little bit longer. So sometimes in an orchestra or the band, it'd be like, hey, we're now going to hit the drum solo. Hey, you know what? Because the crowd really loved it, I'm going to go hit that drum solo again because that drummer's amazing, and then do it again. So think about that as the ability to make the decisions to accomplish the goal. what I like to do though is there's so many business applications from a LangGraph perspective. So I just talked about financial services, but we can also talk about healthcare too, right? Because we have Thrive AI that came out, but same kind of concept. Imagine not imagine, it's going to happen where all your health data, your Apple Health data, so you have that. Then you have the latest in, I don't know, whatever, let's say
Sleep technology.
Sure, sleep tech. You have all your sleep data, sleep technology data, and it's analyzing both. And then you have questions against, hey, my sleep is this. I haven't been sleeping well for the past week. What's happening? Analyzes your sleep data, analyzes the latest, and pulls your medical records from that would be your database from wherever it is. So now is it all these sources of data pulled together makes analysis for you. You didn't have to go to the doctor or a sleep expert. You have the sleep expert based on all the things that a sleep expert would have to pull that would take a long time. But now it could do it for you in seconds.
Right. So I'm going to take that that example and expand it just slightly. So your sleep data is there, the food you're eating is there, and your blood sugar levels are there, right? So this is the decision: do I need to schedule a sleep study to see whether I need a CPAP machine because I have sleep apnea, or is my blood sugar dropping? And therefore, I need to do something with protein or whatever I'm going to do in terms of food, right? And that typically in the past has been like, hey, doc, about 3 o'clock in the afternoon, I'm crashing. Why is that happening? But now you're collecting your own data. You don't have to have that conversation with a doctor, let's theorize. You have it. Okay, it didn't happen 2 days ago, and this is how that circumstance went. And it did happen these other days, and these are the data that lead up to that. And now you can make some predictions.
I think that's the key thing that puts this all together is does your agent know enough when to pull certain data, when to review certain data? And I think that's the thing that holds this all together is the better the reasoning capability, the better it can know which node to pull, which actions to execute, which things are conditional, which are not. So that's why I had a pause on LangGraph, because I'm like, wait a minute, if the reasoning is better, then you don't need to build as many edges. Maybe you don't even need to build as many nodes because it understands how to use the whole thing much better than, let's say, you try to build this with regular GPT-4 Turbo, right? Think about the education space. Understands everything that you've learned, everything that you're supposed to learn, everything that tests you've taken, all these things, every actions that you've taken, all that stuff, combined with courses, combined with learning paths from students that in your level, your quote unquote ability, and then tailorized a virtual tutor that can assist you really personalized to what your needs are, as all assessed. I don't think there is a level of tutor that would be able to understand that at the moment. The power of that is ridiculous, because, and we're not talking about we're talking education in general. So for adults too, I want to learn about, or I want to learn how to play the guitar. Well, it's taken in, what you've learned so far, how you've played, analyze how you played. Oh, these are the things you need to do, hyper personalized to, hey, I think we need to work on this. I don't think it's not thinking, it's based on all your history. And then the questions again, I thought potential is pretty big.
So Justin Sweetly is thinking we need to patent that idea. And of course, that is, we like to shout him out, another $1 million idea brought to you by the Daily AI Show. This is why I need to be here, because it's all happening. Absolutely. So I think we're going to call it there. Are there any last wrap-ups? Massive, absolutely need? No. Okay. So thank you so much. This has been a fascinating conversation. I am definitely going to be thinking about it, and maybe we're going to bring it back in our recap show.
Thanks, Karl.
Yeah, Karl took
thanks
us.
a lot, Karl. It's good stuff.
And this is why we ask Karl these questions, because he brings it for sure. Okay. So tomorrow is Friday. We're going to do a deep dive into Runway's Gen 3. We are a weekly show Monday through Friday. If you have not liked and subscribed, we would love if you did that. On Sundays, a newsletter comes out and we try to add a little bit more information than we got to in the show. There's also jokes, cartoons, all kinds of stuff. So you can do that at thedailyAIshow.com. And on that note, thanks everybody. Have a good Thursday.
Aloha.